Hello, this is IT Taro. I would like to learn AI this time. I would like to thoroughly understand the most basic convolutional neural network in deep learning. We will actually create an AI program and learn AI with teacher data. Finally, we will check the performance by judging the handwritten numbers by AI with the mouse. I feel that there are many explanations for beginners that are biased toward practice or are too difficult to understand, so I focused on making it easy to understand both the content that shows what AI is and the programming practice. ChatGPT, which is rapidly spreading now, seems to connect words with a high probability of following to make sentences. It is said that it can handle 5 trillion words. ChatGPT is also used in this video. AI is really going to be a basic skill from now on. Therefore, it is important to understand what AI is, and we will practice it using Google Colaboratory, which anyone can use immediately. Let's check what we're talking about this time. Here is the table of contents. In the first item, I would like to understand how artificial neurons and neural networks work, and to understand the rough image of AI. In the second item, we will check what it is like for Google Colaboratory and the MNIST data for training. In the next 3 items, we will create a convolutional neural network program and understand the model and mechanism. The fourth item is to run the program using Google Colaboratory and let AI learn the data. In addition, using the created AI, we will check the performance by judging handwritten characters with a mouse. All the programs used this time are published on the Hobby IT site, so please refer to them if necessary. Move on. First of all, we will understand the most basic content of AI. It is a linear simple regression and has a linear function relationship. Regression is the same as prediction. Suppose you have a data plot that can be represented by a straight line like the upper left figure. We are looking for this relational expression. The reason for obtaining the relational expression is to predict the y value from the x value even for values without plots. Given data, it derives a relational expression, and I think it will be a predictable AI. Considering the rightmost plot, the error from the line of the desired linear function is the actual value of y1 minus the value of the linear function, x1 plus the value of b. Increase. The same thing can be said for all plots, so if you add them all, you can find the total error. However, since it depends on the plot whether the error occurs on the top or bottom, the squares are summed. The parameters a and b that minimize the sum of these errors are the formula that expresses the relationship of this data. This is called the least squares method. In this way, finding a relational expression that minimizes the sum of errors is the same way of thinking in deep learning. I think it's important, so I've summarized it in the lower right frame. Many AIs decide on a model first. Next, the parameters are determined so that the total error due to the learning data is minimized. The sum of the errors is called the loss function, so keep that term in mind as we will use it later. Move on. Next, we will understand perceptrons and artificial neurons. This will model the movement of brain cells, as shown in the diagram above. Specifically, as shown in the figure below, artificial neurons have inputs and outputs, just like nerves. Each input is weighted and computed in a neuron. The calculation formula is displayed as a judgment formula, but the value obtained by multiplying the input by the weight and summing all the values is compared with the threshold value. If it is larger, it will output 1, and if it is smaller, it will output 0. As shown in the example below, if each input is 1, 2, 3, all weights are 1, and the threshold is 5, the formula is satisfied, so 1 is output. Increase. In the explanation just now, the output is either 0 or 1, and the step function is used. Each neuron will output based on a predefined function. For reference, the functions that are often used are introduced on the right side. First, just understand that various functions are used for output. Move on. Understand neural networks. This will be used by connecting the artificial neurons mentioned earlier like a network. The simplest neural network consists of an input layer, an intermediate layer, and an output layer, as shown in this diagram. This time, the figure shows an example of judging the images of Maru and Cross. We will learn about specific movements. The input layer has the role of simply passing the 3x3 resolution signal to the intermediate layer as it is. In the next hidden layer, the incoming values are weighted. This weight determines which feature is captured by the neuron. For example, if the Y1 neuron captures features where the top left and middle are black, the weights of x1 and 5 are increased. The higher this weight, the higher the output when matching the image. The output of the hidden layer is passed to the neurons of the output layer. The output layer is similarly weighted. In the output layer, there are 2 neurons for judging Maru and Cross. In this figure, the image of X is input, so the weight of the output of the neuron that matches the feature of X in the intermediate layer is increased. So the weight from Y1 to Z2 increases. In this way, when the X pattern is input, the weight of the intermediate layer that matches the feature increases, and the weight for the neuron determination of the output layer also increases, so X is determined. Increase. The expressions output to these neurons are shown on the right. Since these relational expressions are the loss function, the error can be calculated. The weight and threshold parameters are determined so that this error is minimized. Next, let's take a closer look at this topic. It shows an example in which the variables described in the previous figure are replaced with specific numerical values. As the data to be given, the input training data and the output correct data are given as a set. The data to be optimized will be the numerical value in white. Specifically, the weighting and threshold of each neuron in the intermediate layer and output layer are optimized. Since many patterns are given to the learning data and the correct answer data, the parameters are optimized so that all patterns are close to the correct answer. In other words, AI learns by optimizing this weighting and threshold. Features are captured where the weight in the intermediate layer is high, and the weight of features that match the judgment of Maru or Cross is high in the output layer. By learning in this way, it becomes possible to recognize and judge images. Move on. Next, check the development environment and learning data to be used. The development environment uses Colaboratory provided by Google for free. Anyone can use it immediately with a web browser in an environment where the programming language Python can be used. Free use is a little limited, but it has enough performance for personal use. In addition, MNIST is used for training data. It is open to the public for free on the internet for AI learning and can be used by anyone. We also have 60,000 pieces of data for handwritten numbers, so we will use this. Now let's see what it actually looks like. First, using Colaboratory, create a program that displays what kind of image the MNIST data is. Since it's a basic program, let ChatGPT create it for you. If you ask a question, it will create it like this, so copy and paste this to Colaboratory and check the MNIST data. Now let's run it. First, search on Google and open Google Colaboratory in your web browser. Go to Google Colaboratory and when asked which page to open, click New Page. There is a code input field, so copy and paste the program created with ChatGPT earlier. After copying and pasting, click the Run button on the left. If it runs normally, the image data of handwritten digits will be displayed. There are actually 60,000 sheets, but I don't think it's necessary to check all of them, so I'll only display the first 25 sheets. It will be 28 times 28 size handwritten data. I would like to use this to learn AI. Next, we will create an AI program that recognizes handwritten characters. This is also a basic program, so I asked ChatGPT to create it. If you ask a question like this, it will create a program for you. The program does not require modification and can be run as is. I will check the contents of this created program. In ChatGPT, the program is displayed separately for each part, but since it is the same regardless of whether it is executed individually or collectively, it is summarized this time. Since numbers are attached with circled numbers, I will explain with those numbers. Defines the first library to use. It is the most basic library used in AI. Second, we prepare training data. MNIST data is read separately from the internet for training and validation. Also, the data format has been changed to a format that uses it. The third defines the AI model, and the fourth shows it. The fifth is to set the parameters for learning, and the sixth is to actually learn and optimize the weight and threshold parameters of each neuron. Finally, the seventh shows the accuracy rate and the value of the loss function with the validation data, that is, the new data that has not been trained. The third and subsequent points are important for understanding the mechanism of AI, so we will understand in detail in the following slides. Move on. Here is a rough diagram of the convolutional neural network we will be using. First, deep learning refers to neural networks with two or more intermediate layers. In addition, the convolutional neural network is a method of learning by subdividing in the intermediate layer. For details, I would like to confirm the contents from the next slide, and finally confirm this overview again. Move on. We will understand how each layer works. The first is the convolutional layer, which is represented in the program like this. In the convolutional layer, feature extraction is performed with a size called a filter or kernel. Kernel and filter are synonymous. Using a 3x3 filter, the entire image is checked by shifting the 28 size by 1 pixel, so it can be divided into 26 sections. Since we shift the entire image with the same single filter, we are doing feature extraction on each of the 26 by 26 segments. Since 32 filters are prepared, 32 types of feature extraction are performed. So all 32 filters have 26 times 26 outputs. The neuron activation function uses a ramp function. An activation function is used that can increase the output according to the degree of feature matching. The reason why we perform feature extraction by subdividing in this way is to reduce the parameters to be optimized and perform feature extraction efficiently. This means that feature extraction can be performed more efficiently than inputting the entire image with one neuron without subdivision and preparing several types. Move on. It will be max pooling layer. The program will be one line like this. It will play the role of extracting only the maximum value in the pool size. As shown in this figure, only the maximum value within the size of 2 times 2 is output. So the output size will be half the size. As a result, it is possible to capture rough features and extract features that are resistant to deviations. Move on. This will be the flat layer. This will be the layer for rearranging the existing neurons in one row. It does not change the numerical value, so it can be said that it is a layer that arranges the data order for the next layer. Move on. It will be the dropout layer. This removes neurons randomly at a constant rate. This time it is 0.5, so 50% of random neurons are removed. This is known to be effective in preventing overlearning. If we understand overfitting using the example of a linear function, as shown in the figure on the right, it means that the desired straight line is over-optimized for the given training data, resulting in a biased relationship with the data. In such a case, the data that you actually want to predict will be misaligned, making it impossible to obtain accurate relationship values. Excessive bias in training data is called overfitting, and it is one of the things that we should not be particularly careful about. Move on. Finally comes the dense layer. This is a fully connected layer, meaning that it is connected to all the neurons in the previous layer. This time it is used for the output layer. The output layer of this model judges numbers from 0 to 9 with 10 neurons. The activation function will be the softmax function. It is a function in which the output changes greatly as the input increases, and each neuron has a relational expression that indicates the ratio from the whole, so if you add all the numbers from 0 to 9, it will be 1. You can indicate the judgment ratio from 0 to 9 with the whole as 100%. Move on. It will be the entire model that was confirmed first. For the input image data, feature extraction is performed by filtering in the convolution layer, and rough features are captured in the max pooling layer. It is designed to do this in 2 stages, and rearranges in one row in the flat layer. In order to prevent overfitting in the dropout layer, it is deleted at a certain rate, and finally the dense layer outputs the judgment rate from 0 to 9. Each neuron has weights and thresholds, so there are a lot of parameters to optimize with the training data. We will check the optimization including the program. Move on. I am setting up optimization programmatically. First, we specify the loss function. It is a loss function that is generally used when classifying from 0 to 9 like this time. Second, the optimization algorithm utilizes Atom. It is widely used as an improved version of gradient descent. We'll see what gradient descent looks like in the next slide. Next is the index for evaluating AI. This time we are setting the accuracy rate. This indicator is used during training. Move on. Before using the gradient descent method, let's check how to solve the equation. I think it can be broadly classified into these 2 categories. One way is to transform the formula to find the answer. It will be the method on the left side of the slide, and you will be able to find the correct answer, but only if you can find the equation by transforming it. Another method is to find the answer by substituting temporary values, like the method on the right. Here, it is possible to find the answer even with a complicated relational expression. Relational equations with many parameters, such as AI, are difficult to find the answer by transforming the equation. Therefore, we will find the optimum value by substituting temporary values. Move on. As for the gradient descent method, as I mentioned earlier, we will find the optimal value while substituting values. Since the loss function is the error, the parameters are obtained so that it becomes small. Each neuron's weights and thresholds are given random initial values. By doing a partial derivative of the parameters and calculating the slope of the loss function, we can see in which direction the loss function is smaller. We will move the parameters so that we can grasp the slope and make it smaller. This is the image of gradient descent. There is a point to note here. Is the learning rate. This is how much to move the value of the parameter. Since the loss function has a very complicated relationship, it is difficult to express it on a graph, but if the graph is as shown on the right, the value to be sought is the bottom of the first valley, which has the smallest value. If the learning rate is too small, it will not be able to cross the second valley and will move toward the bottom of the second valley. Conversely, if it is too large, it will be difficult to find the bottom of the valley, and it will be difficult to find the minimum value because it will exceed the bottom. Improvements are being made, such as the learning rate becoming smaller as learning progresses. Move on. AI actually learns in this program. The first parameter sets the validation data to 0.1. This means that 10% of the 60,000 image data will be used for verification. Therefore, 54,000 images are used for learning, and 6,000 images are used for verification. The data is divided because it is difficult to determine whether the optimization is specialized for the training data when verification is performed with the training data. Next we set the epoch. One epoch is an optimization process that has been learned through 54,000 pieces of data. In other words, one epoch is to learn all the prepared data. Since it is set to 15, it means that 15 optimizations will be performed with the training data. Then set the batch size. Sets the number of images to be processed at once. Since 54,000 sheets are processed 128 times each, one epoch is batch processing 422 times. Move on. Finally, we will evaluate AI processing with test data. AI is evaluated using 10,000 pieces of test data. The value of the loss function and the accuracy rate are displayed for this evaluation. You can grasp the performance of the AI with this final evaluation. I have checked the program. Now let's make it work. Click the plus code mark on the upper left of Google Colaboratory and copy and paste the program. After pasting, run it. The model is displayed first. This is only displayed for confirmation. Learning will then begin and progress will be displayed. As you understood earlier, 422 batches are processed in one epoch, so you can check the progress. It will be completed after 15 epochs. You have completed your studies here. At each epoch, the loss function for loss and accuracy for accuracy are displayed. The parameters are adjusted so that the value of the loss function is 0, so the smaller the better. The accuracy rate is the percentage of correct answers, so the higher the better. For loss and accuracy, the value with val is the value for verification. And the accuracy rate for verification is low, there is a possibility of overfitting, so be careful. At the bottom, the loss function and accuracy rate are displayed for the test data. The accuracy rate is over 99%, so it can be said that the performance is good. Now, let's actually do handwritten numbers with a mouse. I have already created a program that can handwrite numbers, so I will copy and paste from the Hobby IT site. This time, the AI program is the main, so I will omit the explanation of this program. When you run it, there is a handwriting space, so you can handwrite with the mouse here. I will write 7. There is also a clear function, so it is possible to erase it. I will write 6. Let me judge here. First, it is changed to the size that AI judges. 28 size image is displayed. Judging by this image. As shown in the graph, the judgment ratio of each numerical value is displayed. It can be seen that 6 is properly determined. I'll try another one. Let's judge 3. 3 can also be judged normally. You can see that the AI is able to judge normally. We have confirmed the operation, so that's all for now. We will continue to take on the challenge of making things using IT like this, so please give us a high rating and subscribe to the channel. See you next time.